So today we are going to continue the lesson Matter in Our Surroundings, the chemistry chapter of science textbook NCERT, chapter 1, class 1. So let's discuss what happened in the last class. Last class we discussed about the physical nature of matter and what is matter. If you wanted the detailed explanation, I have posted the link below. Please click the description and watch it so that you will get a clear explanation. So now let's see the states of matter. In this class we are going to detailedly see the states of matter. So the first state of matter is, which you have already learned, solids, after that liquids, and after that gas. Now these plasma and BEC is optional. It is not needed for your level, but I have written for your sake. It is an extra information. So let's learn detailedly about the states of matter. So the first state of matter is solids. Let's see what is a solid, what does it have. So solids, the particles are very tightly to each other and they are tightly packed. I hope you all learnt about it in the previous classes. So also the solids doesn't have space between them. There is no space between them as they are tightly packed. Now solids, they only vibrate. The only feature they do is vibration. They vibrate to pass on the energy. So let's go to the second state of matter, which is liquids. Now liquids are loosely packed but not freely packed. They are loosely packed. They are partially loosely packed. Next, they have intermolecular space. What do you mean by intermolecular space? Now let us see it deeply. For example, let's have a beaker in which we have water. So here, inside the water, if we zoom it in the microscope, we can see that the particles are loosely packed according to the state of matter we have learned it now. So it is loosely packed like this. They have space between them. So this space is called as intermolecular space, which I have written in short IMS. So they have intermolecular space present inside them. This space, see, there is a space here, right? This portion I have shown, right? This portion is called as intermolecular space. These small round-like structures are the molecules of water. So I hope you all could have understood it. Now let's move on to the next feature. Subspace. They have only some space, as we see here. They have some space but not so much of space. They have some space between them. So let's go to the next state of matter, the last state of matter according to your textbook, which is gas. So gas is randomly packed. It is not like liquids present here. If you see, liquids have some space but they are not randomly packed. They are orderly packed. But gas is randomly packed. They would be like, just a minute, I will show it. For example, if you see, this is the zoomed version. Here is a molecule and here is a molecule. Here is a molecule, here is a molecule, here, like that. They have so lot of space compared to here. Here it has only small space, but here compared to that they have a large space between them and they are freely packed. They are not ordered. So this is what means randomly packed. Also, intermolecular space is more. If you compare to liquids, the intermolecular space is more. If you see, between these two molecules, the inner part has more than liquids, which means they have the intermolecular space as more. If you see, the IMS is more. So if you see, they are also freely packed. They are not tightly packed. They are not loosely packed, but they are freely packed. They are allowed to go wherever they want. They are allowed to spread. If this is here, after some time it moves here. this moves here. Like that, it is freely packed. It can move wherever it wants. But a solid cannot. This is what is there. So, we have a comparison between solids, liquids and gases for both intermolecular space and intermolecular force of attraction. So, first if we take intermolecular space, the liquids have less intermolecular space compared to solids, and also gases have less intermolecular space compared to liquids. So some still have the doubt that whether this symbol is lesser than or greater than. So there is a simple trick. The symbol which has L-like shape is nothing but the lesser than symbol, and the inverted L-shaped symbol is nothing but the greater than symbol. That's all. It is so simple. So let's move on to the intermolecular force of attraction. So intermolecular force of attraction means, actually I said you about the intermolecular space, but the intermolecular force of attraction means, if you see, this is a box, the zoomed one. So here we have solids which has tightly packed molecules. If you see, they are so tightly packed that they don't have any space between them. Here I am randomly drawing. Okay. So here they don't have space. So if you see, the force of the attraction is more. If you see, the both molecules attract more. That is why if you see here, but also they don't attract objects easily. That also is a matter. So this is nothing but the force of attraction. So now if we see the intermolecular force of attraction, then see that solids have greater force of attraction compared to liquids, and liquids have greater force of attraction compared to gases. If you see, here also solids have less intermolecular space compared to liquids, and gases have more compared to liquids, which means liquids have less compared to gases. So if you see, the space here in the gases are random, so the space is more. So gas has the more intermolecular space. Here solid has the more intermolecular force of attraction. So if you see, solid is for intermolecular force of attraction and gas is for the intermolecular space. So let's move on to the properties of state of matter. So they are so simple, you would have learnt it in your lower grades. So let's move on. Properties of the state of matter. First I will erase it because you guys would be confused with gases and solids. So now if you see solids, these solids have a rigid structure. They are so rigid. They are so thick, rigid substances which could be broken. If you see, liquids and gases cannot be broken. We cannot break it. But if you see, solids can be broken. So they have rigid structure, and solids have definite shape, size and mass. Their mass wouldn't be. So if you think this may be 1 kg, it remains to be in 1 kg unless we add another solid into it, or else we add some other state of matter into it. So here if you see, they have definite shape. Their shape doesn't change, okay? Their shape never change unless some substances like a sponge, if we put pressure, their shape changes, but not throughoutly. If we release it, then it gets released and it comes to its original position. It can't be changing its state. So Next, its size can't be changed unless it is broken. So now, it can't be compressed. Compressed means if it gets compressed, then it will be broken into pieces. If you use a hydraulic press and if you put it in a solid, for example a box, it gets crashed, it doesn't get compressed. It can't be compressed inside, but its mass, its size and these things wouldn't be the same again. So it can't be compressed, it can be broken. If it is compressed, it is broken. Now, it does not flow because with a solid flow, it is a common question. No, it can't flow. It has high density. If you compare to other state of matter, solid always have high density because they are tightly packed, they have rigid structure and they can't be compressed, so that they have high density. Due to these all reasons, it has a high density. So I guess you all could have understood it. So let me move on to the next state of matter properties. It is liquids. So liquids, they don't have a definite shape or size. If you see, they don't have a definite shape or size. They take up the shape of the container which they are inside it. If you see, here is, I will take here itself, this is liquids. Liquids. Here, if I add some water, this can be measured only in volume. If this is 1 ml, for example, but 1 ml can't be this much too much like this. Okay, let me take it as 1 liter itself, no confusion. So 1 liter, here I am adding 1 liter of water. Here it is like rectangular in shape. If I add it in a thin one, it would be till here, 1 liter. So it takes up the shape and size of the container. It doesn't have a fixed definite shape or size. Okay, let's move on to the next property of liquids, which is they have definite volume. I already said you that the volume doesn't change in every container. If you see, already I showed you in a container which is rectangular in shape, it is like rectangular in structure, and if it is so thin, it is so tall that structure. But its volume doesn't change. It is same still in 1 liter. It can't be changed as from 1 liter it became 250 ml, 250 ml like that. Okay guys, so let's move on to the next property, which is it can be compressed. If you see, if we tap a water, if there is a water can and we put our hands inside it, and if we pressure it, the water will move on and bulge into other sides and it goes upwards. You all would have experienced it. So it can be compressed, but its volume wouldn't be changed, because if we compress it, the volume will move on. The water molecules will move on and go up because they are loosely packed. So that if here it is there, if we put a pressure, this person will go here into this intermolecular space. Inside this intermolecular space, one will go inside. If we put a pressure here in this molecule will move here. So it can be moved better. That is why it can be compressed. So now let's go to the next property. It flows easily, which means it has the property of fluidity. Let me write the spelling so that you will be clear. Fluidity. Wait, I will write it top. There is no space here. Fluidity. Did you see it? In your 8th standard you would have learned about it. Fluidity in your lessons. So now, it can flow easily, which means if we open the can or if we spill the water, it flows easily. If we spill the water in the floor, it flows here and there, it moves here and there because of the air, because of the gas, which makes it to pressurize and move that side as we do as compression. Okay, the next property is it is less denser. It has less density because it is not tightly packed and it can be compressed. If it can be compressed, then it should be less denser, right? If it has more density, how can we put a pressure on it? And how can we put a pressure and our hands will hurt, right? If you put a pressure on a solid, then how will it play? How will it pain? You all know, right? So like that, if we put a pressure, it shouldn't pain. So it is less density. But we can't say that it doesn't have density itself, but it has less density. If it has less density only, it can move easily. That's why we say that it has less density. Now, the last property of liquids is all states of matter can diffuse into liquid. This is the very important property because if you see, so the diffusion in all states of matter can diffuse into liquids. So let's see how can it diffuse. So from the diffusion of liquids, it can diffuse into liquids. For example, solid can diffuse into liquids on the process of melting, and gas can diffuse into liquid in the process of condensation. So I hope you all could have understood it. This is how they say the statement, all states of matter can diffuse into liquids. So let me say the next property of gases, the next state of matter. Lastly, let's start the properties of gas. So let's start. No shape and size. Gases doesn't have shape and size always because they are freely packed and they are random. So they can't be seen. Actually, gases can't be seen in our naked eyes. You all know, right? At the same time, it doesn't have shape and size. Next, it has a definite volume. If you see, nowadays, we are saying our AC air volume as tons. This is also a measure. This is greater than kilogram, which is kg. So we use the term tons for gases. If you see, for nitrogen also we say tons of nitrogen, tons of oxygen cylinder. So in oxygen cylinder also there must be a value, right? There must be a measure, right? So to measure, the one key term used is volume for both liquids and gases. So next, they can be compressed easily. If you see, like if you there is something freezing ice, or if you put your hand into the refrigerator, there are some air particles. There are some air particles inside it. There are more air inside your refrigerator. If you put your hand inside, you can feel the touch of the air in your hand. It would be like smoking sensation. So that time, if you press it, it moves upwards. As you already know that, see, these are the molecules of gas. So if you see, if you put pressure on this will move here, and if you put here, it will move here. So it will exchange the position. So it is compressed very easily than liquids. For liquids also you will feel the touch, but for gases you can't feel the touch. So next, flow easily, fluidity. We already saw this property in liquids. The same properties seen in liquids are actually flow easily, fluidity, compressed easily, but they are compressed very easily They are compressed more easily than liquids. So next, they have definite volume. This also we saw in liquids. And here, we also saw that there is low density. We also saw about density for solids. So here, they have very less density than liquids. Then imagine, they have so less density that it is like smoke, it is freely moving, it doesn't have any mass or weight for it. So you see, but it has weight as a group, but if you see normally it doesn't have so much of weight and it is so weightless. If you see, if you put it like this, if you are sitting in the AC or if you are sitting under the fan, if you do like this, you can feel the air. That time the air feels so lighter. How lighter is this? If you sit in near a breezing area, if the breeze comes, you will feel like how light is this breeze? No weight at all, but so much of air, so much of chillness. The same thing can be explained here. It has low density. The last property of gases is it diffuses into one another state of matter. Same like liquids. This is also important. Both liquids and gases diffuse into all the states of matter. This is so important. The both states of matter are gases and liquids. Now, for liquids, we saw how it diffuses. It gets diffused in all states of matter. Now, let's see for gas. See here. For gas, when solid gets diffused into gas, the process called sublimation occurs. You already know about it, right? From solid to gas. For example, you already know about it in your lower classes. From liquid to gas, you already know about it. Vaporization. From the sea, the sun extracts the water in the form of gas, which is the process of vaporization. So through this processes, we see that all the states of matter gets diffused into the gas state. So let me recap what and all happened in this session again before we end up this video. So at the first we saw what are all the states of matter, the things which are needed and which are the common properties also we can say that. Okay, so we have seen about solids, liquids and gas and the properties of solids, liquids and gas, and also the diffusion occurring of both gases and liquids and the similarities of gases and liquids, and also about the intermolecular space and intermolecular force of attraction and the comparison chart. So thank you guys for seeing this video. Please subscribe our channel if you like this video for more videos. If you want another part of any other subject of class 9 NCERT book, please comment it below, and also I will meet it in the next part. Please comment it below, share this video so that you can help your other friends to learn too. And also like this video. Thank you so much for watching guys. Bye bye. Thank you.